Welcome to LNP Renewable System Director. Today we are going to discuss some of the basics of PLC ladder logic. Okay, if you're a building management system engineer or a BACS engineer, what are the basics that you need to know in the ladder logic? So those concepts we are going to discuss today. So today we are going to discuss the part 3. Okay, if you missed out part 1 and 2, in the description below we had provided the link. By referring that link, please watch that video also. So it will be the discussion that we are having now will be will be easier for you for your understanding. So please refer the part 1 and 2. So what are the concepts that we're going to use? So as we are from the electrical background, okay, maybe the logical gates we might have heard out: AND gate, OR gate, NOT gate. Okay, so in the last session we had discussed the NOT gate. Today in this session we are going to discuss how we can implement the AND function in the ladder logic, how we can implement the OR function in the ladder logic, and what are the different types of timers available in the ladder logic. Okay, how we can use those timers, for which functions we can use those function timers, and even for counter functions also is there, that is count up counter, down counter, like so many concepts today we are going to discuss in the ladder logic. Okay, and also for the comparison functions also we have different varieties. So we are going to know the basic varieties inside this ladder logic, and also even max functions also there we can implement in the ladder logic. Okay, and basic how the PLC memory maps are there in the Allen Broadley, that is Rockwell software. So as we told earlier in the AND function, and by seeing this concept you can easily able to understand that if both the input 1 and 2 are on, then only the output will be on. Okay, see here we have a motors. Okay, just an example we had given. Okay, if you want to enable an output, if this is in the NO contact, this is also in the NO contact, if both are on, then only the output will be on. This is the if then function. Next we are going to discuss the ladder logic. Okay, logic gates. If you're going for a truth table, how it will be looks like. If both the conditions are false, the output will also be in the false. If if one is false, other one is true, the output will be false. If input A is true and the input 2 is false, the output will be false. If both input A and B both are true, then only the output will be true. So this is a basic concept of AND logic. Same thing we are showing here with the ladder logic. See here we have two inputs. If both inputs are false, the output is false. Even the input B is enabled now, but we can't see any output. Even if you switch off this B and we are just enabling input A, there won't be any output. If both inputs are on, if both are true, then only the output will be. So this is how we can implement the ladder logic basic gate and gate inside this ladder logic. See here the same concept will explain you with the simulation. Okay. How? So we have two inputs, I0 and I1. Okay, we have this is our rails. This is the rung, one horizontal rung. Explains the concept of AND here. So if both inputs are on, only when the output will be on. If the both inputs are off, the output will be off. If one input is on, there is no use. The output will be in the off. Okay. If the whereas in case of the second inputs are in or on, the output will be on. In the OR operation, we can create in a both combining both, we can understanding purpose. Let us try to check how the ladder logic. Okay, see now we went for a simulation. When we enabled I0, there won't be any output. Okay, and if we enable I1 and I0 both, for sure we will have an output. Okay, and now if you off the I0, okay, what will happen? There won't be any output. Okay, if both inputs are on, then only the output will be on. So this is how we can implement our AND function inside a ladder logic. Okay. In the same OR concept also we had provided example here. See here, consider the I3 and I4. If any one of these inputs are on, for sure there will be an output. See here. So if I3 is on, we have an output on. Okay. And the I4 is also on, the output will be on. Even if we off I3, with the help of this I4, the output will be on. So this is how the OR logic we can implement in a ladder logic. Okay. So for the OR logic, we provided the concept here. Okay, if any one of these inputs is available, then you can enable the output. See here, this is an example of a lamp which is getting enabled with a multiple switches. Here AND concept is also there. Okay, if you see in the series, AND concept is also there, and if you go for a parallelly, the OR concept is there. If any two of these inputs are on, we can enable the electrical output. If with the help of a single output also, and with the help of multiple inputs we have, we can enable the single output. So as we all know, the truth table for a OR gate is, if any one input is true, for sure our output will be true. If both the inputs are false, then for sure it will be false. Okay, see here both are false, the output will be false. Here one input is on. Okay, B is true, so we are getting the output. If A is true, also we are getting the output. If both are true, we are getting the output. Okay, so the same video which we saw earlier. Now the output is on. So this is an example. Let us see the OR functioning inside the simulation. I0 off, the output is off. See, this is the best example of the AND. Now see how a OR gate will. So now 3 output 1, 3, the output is C3, I3 is enabled and we are getting the output, and I4 is also enabled, we are getting the output. Even if only when I4 is on, we are getting the output. So this is how OR logic we can implement inside a ladder logic. And what are the type of timers we have? We have on delay timer, we have off delay timer, and even we have a timer with both the functions. Okay, see here, this is an on delay timer. Okay, here what we done, we have used we are enabling this simulation using the timer on and off function. See here, we have one timer with a value of 5, that is 5 seconds. Okay, let us see how the T on will work. T on will work immediately when the input is enabled 5. Okay, it will be 1, 2, 3, 4, 5. Immediately the output will be on. Okay, once we will get a timer done bit, then we will our output will be on. If it is an off timer, when the switch is on, okay, it won't be on. When we disable the switch, immediately it will be on. 5, 4, 3, 2, 1, and the switch will be on. So this is how a on timer and off delay timer will work. Now let us try to simulate it with the help of the simulation video. See here. On delay timer and off delay timer will work. Let us try to see. So we had used two inputs and we had used two different timers. One is on timer, the other one is off timer. See here. And we are using the two timers. One is for on delay and the second one is for off delay. When the input one is on. It is an off delay timer. So let us try to change the set point value of this. If you want to change the value also, we can change. Now let us change the timer value. Okay, let us change the timer value. 6. Okay. So of off delay to 6, and on delay let us change to 4. Okay, importantly, whenever you do any sort of changes, please save it. Okay. Okay, now we are going to start the simulation. Okay, see here what is happening. We are going to check the on delay timer. So when we enabled input 1, 2, 3, 4, immediately the timer 1 bit is enabled and we are getting the output. So this is okay, on delay timer works. Okay, for 5 seconds if you are keeping any sort of timings, after the 5 seconds or 4 seconds, immediately the output will be on. This is how a normal on delay timer will work. Okay, now let's try to check. And now we are going to see how the off delay timer is works. Okay, on delay timer. Now here what is happening, output is already off. Okay, if you want to switch off, okay, see here it is a reverse operation of. See here, by default the output is on. Now here what is happening, because it will be always in the NC contact. Okay, T2 done bit. Okay, now what we are going to do, we are going to make on the I2 on. Okay, that is input 2 switch to on. Okay, and when we off it, okay, what will happen? Okay, see here, it is not on when we enable the switch. It will on only when immediately if we. It will get enabled only when the input 2 is off. See here, 5, 6, 5, 4, 3, 2, 1. Immediately the output will be off once we get the done bit. So this is how the off delay timer will work. On delay timer. And we have, if you go for a comparison functions, we have so many functions. Equal to function. Okay, if both the inputs are equal, then we can make a condition like this. Okay, if both the inputs are equal, then the output should on. If the input 1 is not equal to 2, then we need to enable the output. Like this we can create. Or if the input 1 is greater than the input 2, then only the output should be on. Or we can go for less than concept. If input 1 is less than input 2, then immediately the output should on. Like this. Now with the help of this comparison function, we can create the logic inside it. Mostly it is used for industrial purposes, okay, where we are getting the raw real-time pulses. We can compare and we can get an output, or even with the numbers we can play this, okay. Say for if you're going for a greater than function, if I1, okay, is greater than or equal to I2, then the output should enable. Or if I1 is less than or equal to I2, then the output should enable. Like this, so many comparison concepts we can implement inside this ladder logic. Next, if you're going for a math operation in the ladder logic, you can do addition, subtraction, okay, multiplication, division, okay. Apart from it, okay, trigonometry also you can implement, modulus, expressional, tan, cos, okay, sine, square root, okay. Even if you want absolute values also, you can make with the help of this maths functions inside the ladder logic. So as we told earlier, inside we can categorize the counter instruction to three. One is up counter, down counter, up down counter. See, we have a simple example how up counter will work. We had provided the simulation video also, so it will be easy for you to understand.
Okay, up.
Now see, if
In
the input
counter there
one,
are three varieties:
okay,
up counter, down
we have two
counter,
inputs.
down counter.
One input we
Today we are
are
going to
using
discuss
to enable
how
the counter,
up counter,
okay.
up
And second
counter
input,
will work.
if you
Okay,
want to reset
here we have
the
considered
memory
since
of
it
this
was
counter,
simulation.
you can
We had
go for this
considered
I2,
okay
okay.
the
Now
set
see
point
here,
for the up time up counter is 5 counts. Okay, we can change this counting also. Okay, for your understanding purpose, now we had provided this count as a number of counts as a 5. Okay, see here, now we are going to simulate it. Okay,
we went for a
now
simulation. Now we are
well
enabling the
done.
input one
So we are
once.
making a
See,
switch
the
one
count had
on
changed
one
from
time.
1,
So now the
and
count
if
got
when
1.
we switch off
So we are making
and
it
on
off.
again,
Again we are
the count
making
will
it
change to
on.
2,
So now the
okay.
count had changed to 2. Okay. Once
And
again we are
when we switch off and
triggering the
on
input
again,
1.
it will be
That is we
3.
are changing it
Again,
from
if you go for
0 to 1.
switch off
So that
and
is the
on,
false
immediately
to
the
true.
count
We
will
are
change
switching
to
on the
4,
input 1.
okay.
So what is happening? Now the count is 3. So once again we are making
Now
it to
again,
4.
at last,
Okay,
if you do
we are
off
again
and
switching
on,
off and switching on it
okay,
again. So now the count has changed
the
to
count will
4.
change from
See,
4
if
to 5,
right
since
now if
our
you do it on
set value
5,
is 5,
okay, what will
so
happen is
immediately the
5
output
is a
is
set
enabled,
point. If
okay.
in the
So this is how a up counter will
counter
work.
we can enable
1,
the
2,
output. Okay,
3,
we can
4,
enable the
5, like
output
this. It
if
will gradually
reach
increase,
that particular
okay.
count
But
set point. So
this
here
input
it's
we can connect the event
set
sensor.
point as
If
5.
it
So
went
now the
for
count
5
has changed
rotation,
to
it should.
5. Okay,
If it went
even
for 4
again if you want
rotations,
to make it
okay.
off and
Even for the
on,
precision industry, we can go for this
because it already
counters,
reached its
okay.
set point as a 5. So if the count is 5, the output is
See
enabled.
here,
See
now
here,
the
the
I2,
output is enabled.
if you enable the
Now
I2,
we
what will
want to
happen?
reset it.
The
Okay,
counter will get
because
reset
even with
immediately,
a
and there
single
won't be any
counter
output.
we can use it
Again,
for
we can go
particular
for this concept.
application.
With the help of
Okay,
these two
and
push
again in
buttons, we can
future
do
in order to do
this
your
concept,
operation
okay.
continuously for
And
human
even
purpose,
if you're going for
we need it. So what we need
industries
to do,
where
we need to
packaging
reset the memory
industries,
of
if you
that
want
particular
precision,
counter.
if you're
So
going for a
what we are going
servo
to do,
motors,
we
it
had
need to
put
operate
one input
perfectly.
which
In
will
such
reset the
places, we can go for this count,
counter up
okay.
memory. See here, now what I'm going to do, I'm going to reset it.
So when
So
we
now
enabled I2,
the
immediately the counter got reset.
memory of the counter got reset and the output is unlatched. Okay, so this is a simple example of how counter up work. We had okay.
Next, we are going to see how a down counter will work. So, down counter will work how? Very simple. Up counter gradually it got increased from 1, 2, 3, 4, 5 based on set point value. Set point value, whatever counts you want based on its memory, you can use it, okay. Here also down counter concept we are going to check how down counter will, it will gradually reduce 6, 5, 4, 3, 2, 1, 4 based on our set point it get reduced. So let us see with an example. This is a simulation how
Simulate
it
how
works.
a count down timer will work. Okay, see here we had provided a counter, okay, which has a set point of 6. Okay, so that is subject to change. We're going to do. So now we are going to make the input switch
So
count
now we are
1.
going to
So
simulate
now see the count we are
I1.
changing from
We
6
are
to
making
5.
enabling 1. So the
Again we
count
are
changed from
enabling it. They are changed it to
6 to 5,
4.
5 to 4.
Again we are enabling it.
We
So
enable it
it
changed to
is
3.
changing
If we
from
enable
4 to 3.
input 1,
So again
then
we
it
are
changed to
enabling it.
2.
It's
And
changing
again we are
from
making
2.
it on,
Again we are
change it
enabling
to
it to
1.
1.
And finally
Again
it
we
will
enable
become
the last
0.
one.
Once
So
the
it
counter done we got,
becomes
it will,
0.
our
So
output
after 6
is
counts, it
enabled.
will
Okay.
stop. Okay. Now what we are going to do, we are going to reset the memory of this counter. So we are enabling the
And
counter.
when we press
Okay.
reset push
Input
button
the
using this I2,
counter
the count is
I1 is
getting reset.
reset.
Again,
So this is
we
how
can use the same countdown
operation
operation.
of
This is how the countdown timer will work. 6, 5, 4,
countdown timer
3,
will
2,
work.
1.
Simulate.
So this is a simple example how we can make the connections in order to make the okay counter. See here, we can make a program inside it with the help of this light sensor. Okay, we are providing it as an input for the counting operation. Okay, when the object moves, in order to count these number of boxes, using this we can using this counter concept, counter app or app concept, you can enable. Say for example, if the say if the two boxes are finished immediately, um, the other conveyor should on, like that we can enable, or with the help of this indication we can make. So at the starting phases nowadays we have the analog values are changing counters, but in previously with the help of this lamp indication, if you want to do with the help of this PLCs you can do it. Okay, so how it will looks like in the advanced PLCs, they have the up counter, down counter, and also up down counter also. How we can use it? It's a simple ladder logic we had provided. See here, in that one we had just used only the preset value 5, but in the advanced PLCs it is more than 25 counts, 30 counts you can make. So as we discussed regarding this PLC memory map, okay, for the outputs it will be, this PLC memory map I am providing for Allen Bradley PLC, basic PLC. If you're going for output, you can use it from 0 to 30. If you're going for input, I0 to I30, okay, and binary functions if you're going for B302, B3255, that is 255 256 bytes you can use it. Timer also same, counters also you can use, and even if you are going for any specific controls or integers, you can use from 0 to 255. If you're going for any floating points also, you can use the F8 function. Okay, and for the networking you can go for X9. Okay, and if you want to be precise with the as a user you want to define a file type, then you can use this X10 to X255. Thank you. Please press the subscribe bell icon. Okay, and if you want to know more and learn more, you can contact us. We have provided the contact details in it. And if you want to do projects with us, okay, you can contact us. We have provided the contact details in it. um, we are providing design, installation, testing and commissioning consultancy supports, okay, for the industrial automation, home automation which you want to make using the PLCs. And if you want any training and consultancy supports, okay, for the projects you can contact us. And if you want any training supports for the institutions, if you want to know the PLC basics, you can contact us. We can provide you the trainings. Okay, and also uh, if you want to do solar power projects on grid and off grid, okay, if you want training and consultancy supports, installation, testing and commissioning support, you can contact us. We can provide the contact details in it. And if you want to know the electric vehicle basics, okay, you can contact us. We can provide the contact details. Thank you.